In this video, we're going to see the process of how thousands of pencils are made every day. I'm going to show you how they go from mixes of graphite and pigments to get the right color, to wooden pieces in the shape of pencils, and even the most insane process to make the pencils sharp and ready to use. There is a lot of human labor involved among the steampunk-like machines, from moving the pencil materials from one machine to another to exacting visual quality control. The first factories began in the late 1900s with the Eberhard Faber factory in Greenpoint, Brooklyn, which, like many former factories, has been converted to other uses such as condos and offices. During its time, it employed hundreds of workers, mostly women. The factory produced colored pencils under the name Mongols. They were named that because the company decided to adopt the yellow pencil created by an Austrian company, and under the notions of the time, made them want the name to associate with Asia. Subsequently, they increased the Mongol line to include more colors. The lead inside a pencil isn't actually lead, it's mostly graphite. Graphite is a crystalline form of the element carbon. It consists of stacked layers of graphene. Graphite occurs naturally and is the most stable form of carbon under standard conditions. Graphite is mined by both open pit and underground methods. Graphite usually needs beneficiation. This may be carried out by hand-picking the pieces of rock and hand-screening the product, or by crushing the rock and floating out the graphite. It was discovered in England in the mid-1500s, giving birth to the pencil industry. In 1795, a French chemist invented a new type of pencil lead made of graphite powder and clay fired in an oven, making it possible to produce leads with different hardness. Each pencil color has a recipe to get the right color through mixing pigments with clay and dyes. People mix the pigment into a paste made of additives, binders, and resins. There also can be wax or oil depending on the type of pencil. For example, making a water-soluble pencil requires other ingredients. The paste is put in a cylinder and formed into a cylindrical shape. For the pencil's body, you need a type of wood that's soft enough to sharpen yet strong enough not to bend under the writer's hand pressure. This German pencil factory uses cedar from California. Cedrus trees can grow up to 30 to 40 meters tall with spicy resinous scented wood, thick ridged or square cracked bark, and broad level branches. In ideal conditions, a cedar tree will grow about 25 inches per year. However, it's common for cedars to only grow 12 to 15 inches yearly. It largely depends on the variety of cedar and growing conditions. High temperatures can impede growth as well. The wood is 5 millimeters thick and arrives pre-cut in slats of 18 by 7 centimeters. One by one, the slats pass under a giant cutting wheel. It carves grooves that will become the channel down the middle that holds the lead. The next machine fills the grooves with glue, a special formulation that's slightly elastic. This cushions the lead so that it's less likely to break inside the channel. Every second slot moves on to another conveyor belt. The ones that stay on this line head toward the machine that lays in the lead. The lead is made of a graphite and clay mixture baked in an oven at more than 800 degrees Celsius. The lead-laying machine's wheel loads itself with leads. Their spacing matches the grooves in the slats. It's the same process for colored pencils. Only the leads are made of wax, clay, and pigments with no baking required. How colored pencils are made is similar to how graphite pencils are made, and the same pencil factories are used. Some main differences are that colored pencil leads are not made of graphite, but a mix of pigment, adhesives, and binders. Colored pencil leads don't get heated to as high a temperature as graphite because the colored cores would melt. Colored pencils generally don't get a ferrule or eraser. The ferrule is metal band that's near the eraser of many graphite pencils. Colored pencil leads also don't come in the wide variety of hardnesses that graphite leads do. Wouldn't it be great to have a colored pencil tree? Well, you could look at it that way. Trees are where it all starts. Some big companies like Crayola and Faber-Castell produce their colored pencils from wood harvested from their own tree farms. The trees in these farms are exclusively grown to be made into pencils. Using company farms helps mitigate environmental impact. Now for the slats that move to the other conveyor belt. An automated arm flips each one over, slides it across a glue applicator, then drops it onto a leaded slot on the other conveyor belt. All the steps to this point have culminated in what is effectively a lead sandwich. Now a plunger squeezes those sandwiches together with a full ton of pressure. It compresses them for an hour while the glue dries. After that, it's just a matter of slicing the sandwiches into pencils. This shaping machine makes the hexagonal profile in 2 steps. First, its upper cutter forms 3 sides on top. Then its lower cutter shapes 3 sides on the bottom. As soon as the bottom side is cut, the pencils separate. A worker pulls the sample pencil from each batch coming off the line and manually sharpens it to spot check lead quality. By changing the cutter, the shaft can be hexagonal, round, triangular, square, or many other shapes. Then he applies force to the tip until it breaks. For a pencil to pass this strength test, it has to withstand at least 2 kilograms of force. Now it's time to dress that bare wood. One at a time, the pencils shoot through a device called a lacquering head. It coats the wooden paint yellow in this case. It takes 4 coats of paint to completely hide the wood grain. A 5th lacquering head paints a black stripe, this company's trademark. Then a 6th head seals the paint job with transparent lacquer. From the paint line, the pencils make their way to a stamping machine at an astounding rate of 500 pencils a minute. The machine heat transfers foil lettering from a plastic film to the painted wood. Then the last stop, the rubber tip assembly machine. First, it squeezes the top of the pencil to slide on an aluminum ferrule. Then it inserts a rubber eraser into the ferrule's other end and squeezes that tight. European-style pencils have a painted cap instead, the color indicating how hard the lead is. After a coat of transparent sealer, the pencils take a series of dips in the first color. Then once that dries in the second color. The final coat is a high gloss lacquer. The pencils are finally ready to roll across a grinding drum for sharpening. By the time they roll off, they're pointed perfection, looking as good as they perform. Today's pencils sure have the right stuff. Each pencil gets a careful quality control inspection by humans. The pencils go to a packaging area. They get sorted into color sets and put in the packages we see in stores. They get shipped all over the world. Hundreds of millions of colored pencils are created each year in numerous factories. For example, Faber-Castell, the company which started in 1761, makes about 2.3 billion pencils every single year. And they even once had the Guinness World Record for the world's biggest pencil until they were beat in 2007. I'd appreciate it if you could share in the comments which piece of information surprised you the most, and also which other products you'd like to learn about in terms of their manufacturing process. Before you go, if you enjoyed the content, please give it a thumbs up and subscribe to stay updated on new videos. See you in the next video.